Now, going from Germany to Swiss Re, this is a project that is now up for sale at quite some cost. And this is some of the 3D modeling that we did to generate the building, and I'll go through in just a moment. This really just shows how the slenderness and shape and form of the building cut away with the red elements, the floor plates sliced through that to produce this, and then we twisted each of those floor plates around to create the spiraling form of the gardens. And those were used to generate an airflow around the building. There we go, the cladding on top. So not only is the shape of the building softened because it's in a very tight central location in the City of London, so it opens up at the base, but it also creates softer views around in plan. There you see the site, very tight central London in the city, and the sort of plaza space that can be created at the base of the building, so that people can actually use this as an urban room. And then why the form? If we take again a standard model for an office building with its centre core, cellular offices on the outside. Then we look at a round building, always that problem of how do you do the ceiling systems, how do you plan the space. So by cutting in these indents, not only do you get more of an orthogonal grid, you can also get more light and air into the centre, into the heart of the building. And there is a sort of basic space planning diagram. And then you see the ceiling grids and the floor grids. The only curve that you really have to deal with is on that perimeter, which is also something that we'd learned from the Commerzbank, where the curve on the outside is very slender, and there's just a very relatively small zone that you have to deal with in terms of your lighting grids and all those practical things you have to deal with. And similarly, there's a very evocative sketch of Commerzbank again. So the themes that run through the work on every different project are recurrent, and we're constantly learning. And then again, I won't dwell on this, but using the slenderness and the shape of the building to generate differential pressures, and this is a computer model to test that, a much more aerodynamic building. And if we look at how that wind goes past the building, the pressures of the light blue, very little disturbance down at the ground in that model. And so if we look at how often that building can be naturally ventilated and as opposed to being air conditioned or heated throughout the year, we have a fairly deep plenum wall around the building that takes the heat out through the spandrel panels and has mixed mode operations. There's a little detail showing that this element here is a intermittent duct that takes the air and forces it out at various points through here. There's the air coming up into the fairly deep plenum wall. Early study models of how those gardens may have been articulated, but as we got further and further into the environmental aspects of the project, we realized that this spiral, not only was it more rational, but it also, by taking advantage of the wind that we just looked at in the aerodynamic models, could help ventilate the building, so that if the wind is coming into this portion, it can then start to go up the spirals and help ventilate into those atrium to the offices that are internal. So at those darker areas in the building, you see how these areas open up to allow that ventilation to work. There's a detail. And again, 40% less reliance on air conditioning in this building, much more reliance on on natural ventilation than a normal, typical office building. And there's the top also, where because we don't need so many cooling towers, we can engineer it such that the top of the building creates this amazing space.